So taking a look at number 13 on the back side of the paper, it says group 18 elements. These are called our noble gases. And we call them noble gases because just like the nobility, they don't interact with the commoners. So they are very non-reactive. And the reasoning for that, again, is that they have a full shell. They have all 8 electrons in their outermost shell, so that makes them very happy. They don't want any more electrons. They don't have any electrons to give away, so they're unreactive. So number 14, the majority of the elements on the periodic table, these are obviously, if we look at their staircase that divides the metals from the nonmetals, we have a lot more metals than we do nonmetals. The father of the periodic table, he's the same guy that told the elements where to go. That is Mendeleev. Elements in the periodic table are currently arranged by increasing atomic number. That's a number sign. Octothorpe. It used to be, like when Mendeleev put it together, by increasing atomic mass. But since the discovery of the proton, which is what the atomic number tells us, we have the periodic table set up that way. It helped solve some of the inconsistencies that we saw when it was set up by increasing atomic mass. There were a couple elements that were out of order, like I believe it was argon was stuck over there in group 1, a very reactive group with a non-metal gas in there that's very unreactive, didn't really fit. And potassium would fit in with group 18 noble gases, a very reactive metal in with a bunch of non-reactive gases. So by putting in by atomic number, we've kind of fixed some of those glitches. What physical state does each color on the big periodic table up in the front of the class represent? Well, the blacks are solid, the blues are liquids, and the reds are, let's see, there we go. The reds are gas. And the hollow ones, the outlines, these guys are our man-made or synthetic elements. So this really, the hollow doesn't really necessarily show a state. We can have man-made elements that are gases. In fact, most of the man-made elements are made in such small quantities to not really have a state of matter whatsoever. So let's list the characteristics and properties that distinguish metallic metal elements from non-metallic elements. Generally, metals are good conductors of both heat and electricity. They have a high luster as opposed to being dull, basically a fancy word for saying shiny. They are ductile. Basically, it just means that they're able to be pulled into wire. So one of the things that I think of is like saltwater taffy in the summertime. When it's warm, you can grab it, you can pull it like bubble gum, and it stretches from your hand to your hand. The other one, they're malleable, meaning they can be pounded into thin sheets or rolled into thin sheets. Trying to think of a few other. Generally reactive, but not always. That's not always a good one. But these are a good list of to get us started here. And then it says, answer the following questions about the groups in the periodic table. What element is in group 4, period 5? So we're going to go over 4 columns. That's our group 4. And we're going to go down 5 rows. And that's going to be zirconium. How many elements are in period 4? Well, if we count across, we start with potassium there with the atomic number of 19 and go all the way over across the other side to 36. If we do the math there, let's see, we've got 2, 10. Looks like we've got 18 elements wide. All right, looks like we're running out of time in this video. We'll answer the last few on the next video.